Okay, good morning, and thanks for joining today's session. Let's get started. First, I would like to mention again how your scores will be computed. Let me zoom in and okay. So this is the announcement I put on Husky City. Let's go to this part. Okay, so this starts. So for each exam, there are 20 questions with a total of 100 points. But just like exam 1 and exam 2, I will use about 18 questions to count as the full marks, meaning 90 is considered as 100%. So I will need to convert your score into a percentage, and 100% means 25 points towards your score, your course scores. Because let me get a writing board. Let's see whether I can annotate down here. Let me connect my iPad. Okay, so I can annotate now. So we already know that we have 3 exams and 1 final, right? So each term exam is 25 points, so 25 plus 25 plus 30. So the actual total would be 105 points. But of course, in the end, I will only use 100 to count. There's already some kind of bonus from the final exam, right? You can think there's a 5 additional points, 5%, bonus on final. So in order to get for each exam, okay, what you do is to use your score. So your score divided by, well, total, right? Total usually is 80, not 80, 90. Then you will get a percentage, right? And then you use that percentage times the full marks of the exam. So for term exam, you times by 25, right? For final exam, you times by 30. And then you will convert to an absolute amount for that exam, right? And then you add 4 components together, you will eventually get your, what I call course score, okay? Here is just a quick example. If you have 60, 40, 50, and 45, well, somehow an okay score, as you can see, well, you will pass, right? Given all the curving or all the factors applied. Since I only use 90 as full marks for each exam, it's already about 11% of, bumping up. And for final, it's even higher. It's actually 33%, right? So what you receive is actually either 11% more or 33% more. 11% more on 3 term exams and 33 more on final. So that's quite generous, and that's something I have already decided. Okay. Some of you also ask whether there will be another curving. Well, I don't want to do that because you should have a little pressure, right? It shouldn't be me trying everything, right? I also need you to try whatever the best that you can, right? It's not just me giving you a score. To me, of course, it does not cost me to give you a pass, but still, there should be some education purpose, right? And you register in this course to learn, not to get a grade. So in the end, even if you fail, it's an experience, right? You sometimes you actually learn more when you fail, then you barely make a pass. Because what I often notice, own experience, okay, when I was a university student, I had a roommate who pretty much didn't study at all. He only studied maybe 2 days before the exam. Sometimes he was able to make a pass, but often he failed. He even didn't get his degree because he failed too many courses. But anyway, in the end, it's for those who he actually made a pass, he never looked again. But for those who failed, he actually had to retake it. He actually learned more when he was doing it the second time. Of course, I don't want that to happen to you. But anyway, that's what I have for this portion. Okay. I also mentioned that the exact threshold. I don't have at this moment. Let's move a little. What I did give you is if you have a course score of more than 50, you will be guaranteed a pass. That's why here, the score is 56, 57, but it's guaranteed a pass. Okay, anything more than 50 will be a pass. Below 40 is probably a fail. The exact threshold will be determined once all of you finish the final exam. The basic line is I'm not exactly that strict in grading and giving you grades. So that's why I don't want to put exactly a standard here. Let's say, I put 40. Maybe one of you got, let's say I put 45. Maybe you have someone got 44.9. Right? It's just too cruel to fail that person, right? Then I will downgrade to 44.9 instead of 45. But anyway, I think 50 would be a safe pass, and the boundary would be somewhere not far away from 50. Okay, that's because we already applied many factors, and even that it's 50, and not 60, right? So that's how the final grade will be given. What else? Exam 2. It's close to exam 1. If you go to exam 1, it's here, right? The difference is for exam 1, more people are on the safe ground. The highest is between 60 and 70. That's slightly over average probably. Now we are more scattered. Okay, there are more of you in this range, which is the red zone already, right? So those already in the red zone, and here it's not exactly safe. You have to be always on the right hand side of 50, in order to be on the safer side, at least the 45, right? There are obviously things we can do. So today I'm going to briefly go over. Not even in details, because repeating probably doesn't help too much. We have already done quite enough. So today for the exam review, I will actually try a different strategy, because some mistakes I understand, and I don't even blame you. Some mistakes, actually, I would like you to evaluate why. I don't know. In the end, I only see your options. You pick A, B, C, D, E. I don't exactly see how you worked on each question. That's why I only see the result, but I don't see the process. That's why I suggest you to really compare your own work with my solution one by one, and really diagonalize what went wrong. You can always reach out to me. Let's say we can discuss in details during the office hours, or you can write me emails. I'm always willing to help. A big issue we are having right now is I don't know what the main problem is. So today I'm going to do it in I don't even know how to put. let's say in a more practical way to get the points you need to survive this course, okay? Meaning some of the questions I even simply directly give up if I think it may take me a few more minutes, okay? So let's get started. Question 1. Well, it looks complicated, so I don't solve. So I directly give it up, okay? Let me try to put it a little smaller so I can have the full screen. Okay, that's better. Okay, exam 1, I give up. I probably just make a guess and I come back later. I solve the easy questions. That's enough for you to pass and even more than pass for this course. Question 2, I will solve because it looks an easy one. Okay, so here what I have is from chapter 4, right? We are doing piecely convertible. So it's how do I get it the line to be? So it's 1 minus 1 minus, which one is my annuity? Let me close. Somehow I lost it. Okay, so this is let me put it in my notability. That's probably better because I constantly lost my pen down there. Okay, so I'm here. So question 2. So it's discount, right? So it's discount and it's convertible 4 times a year. So it's 1 minus d4 divided by 4, a negative 4, that would be 1 plus I, right? What I need is v. V is 1 plus I negative 1, which means it's 1 over 1 plus I. So it's just a 1 minus 5% divided by 4 to the 4th, right? So we can even get a calculator. Where is my calculator? Right. So let's put a bracket. Okay, 1 minus 0.05 divided by 4. So that's the, now let's take the 4th. Okay, so we get answer, and the answer is between this, so it's D. Right. So it's pretty much your it takes 15 seconds. Question 3. This is one of the questions I have no idea why some of you didn't get it correct. I always ask you to. Okay, so it's 1, 2, 3 all the way to n. Here's n minus 1, n minus 2 all the way to 1. Adding them together is n plus 1, and it's due, so it stays as a due. Right, so you already got 2 questions correct. 4. Okay, so this is also a nice one because I just want to calculate the accumulated value. Right, so here it's draw the timeline. Right, so sometimes I feel that a lot of you don't even listen to my practical steps. Right? So if your strategy works, you can continue doing whatever you want. If your strategy does not work, let's say you only get 20, 30, right? That means it's time for you to try different things. Means something is fundamentally wrong. Right? If you don't correct it right away, well, it's hard to survive this course or any course. So we have a payment here, 15, and it's right. They are 7 years, right? So again, you can't use your fingers to count. Okay, it always works. Okay, don't always discard those methods, I call it naive. Okay, naive methods work. Okay, that's very important. You start with those. Right, we just need to figure out the effective interest rate. Again, this is discount, right? So it's 1 minus the discount. So it's convertible monthly, so P is 12, right? And then negative 12, this gives you 1 plus I. How many years? We have 7 years, right? So now it's time to get your calculator. So put a bracket. 1 minus 6%, 0.06. divided by 12, put a bracket, so that's whatever inside. Okay, raise the power, put another bracket, 12, where's my negative, times 7. Okay, so then times by 1500. So that is the answer. Now it's 2285, so it's B. Okay, so it's already three questions down. This, well, we actually need formula. If you remember, then this is an easy question because for A, without increasing, it is 1 over delta. And whenever you have increasing, you square that. So it is 1 over delta square. So if you know this formula, then this is rather easy. Delta is log 1 plus I. Right, so what we can do is 1.04. Okay, let's take a log. Let's square, and let's take reciprocal. Well, that's the answer. E. Right. What's this? Okay, 6 looks complicated. Let's give up. What's the next one? Okay, let's give up for now. So, and you see, anything complicated, I give up. So I give you the practical ways to pass this course. Nothing fancy. Of course, after that, I will go back to show you more. Okay, show you more of this annuity, the fundamentals of this course. Question 8 I can do because there are only 5 years. I mentioned more than once that if a question only has very limited payments, forget about any formulas, right? All you need to do is to draw the timeline, label the payments, and simply use calculator. Because so what you want is, what do I want? I want a accumulated value, right? So what I do is, this converted to the end is 401 times 1.06, 4 years. From 1 to 5, there are 4 years. 302 times 1.06, 3 years. Goes on and on to 5. Right? So let's get calculator. Forget about any formula at all. So it's 401 times 1.06 to the 4th plus 302 times 1.06. Now I want to the 3rd plus 203 times 1.06. Now I need square plus 104 times 1.06. And for the last one, it's just a 5. Right? So that's the answer. So that's C. Right? It even doesn't take more than a minute. Right? It doesn't need to analyze. Right? Don't make an easy question more complicated. Right? Once you are writing an exam, the most important thing is to get the right option. Right? The method, I mean, I don't know how you solve the question. You can try to figure out this as an annuity. Of course you can. Right? It's actually very complicated because you have 400, 300, 200, 100. This is a decreasing, right? And this is not even up to 5. And then have 1, 2, 3, 4, 5. Not only you have a decreasing and an increasing annuity at the same time, they are not even matched in time, right? So of course, you can try to apply your formula. That always works. But for an easy question like this, it's simply not necessary to do it that way. Question 9, it looks complicated. This I already mentioned, right? So the difference between with I and without, well, it's to square them, right? A double dot, right? So when you have perpetuity, it's 1 over something. If it's annuity immediate, you divide it by I. Immediate, the first letter is I. Okay, if it's a due, you divide it by D because the first letter is D. If it is continuously payable, you divide it by delta because force of interest is only for continuously payable. And if you have I, you square it. So the ratio is 1 over D squared divided by 1 over D. So it's simply 1 over D. So now the question is, what is D, right? Or what is I? Because D equals I divided by 1 plus I, so it becomes this. Okay, so your job is to figure out I, and that's probably not difficult, right? So here what we have is I6 is 5%. That's because it's convertible every other month. So it's every 2 months. So there are 6 times a year, right? So which means 1 year has 6 2 months, right? It's a little awkward, but it's easy to figure that out. This is 1 plus I, so let's do it. 1 plus 0.05 divided by 6. Okay, raised to the power of 6. That is 1 plus I, and you just need to divide it by I. So divide by 0.0510. 0.0510. I think the next one is 5. Right. So it's 20. Well, it's B. Right. Okay, it's already question 10. Let's go to question 11. What is this? It looks complicated because it's continuously payable. So you must apply formula. The next one, well, we even have force of interest. So let's give up for now. Let's move to 13. The present value of 0 of a payment at time 5 is, okay, so this we can solve. So this is 1,000. The present value is 8, 25, 92, 71. So we can easily establish an equation. This is from chapter 1, right? And here I is the effective annual interest rate. What is the equivalent nominal interest rate per year convertible every 4 months? Okay. So every 4 months. That means it's I upper 3, right? So there are 12 months a year, and I want the frequency to be 4 months, which means 3 times a year. Okay, so convertible 3 times, right? 3 times means every 4 months. Okay, so I need to calculate my I first. Technically, you can keep this, right? So now let's do it. 1,000 divided by the present value, 821.9271. This is this value. Okay, I will need to take to some fractional power. 1 over 5, 0.2. Well, it's about 4%, right? So it's 1.04 on the left-hand side, and well, I can continue to do it, right? I don't need I. I is not needed. I actually need 1 plus I. So I keep this. Raise another fractional power, 1 over 3. Okay, minus 1 times by 3. So this is the answer, 3.95, less than 3.95, 3.94, okay, so it's 8. So here you need to be a little more accurate because 3.95 is one of the threshold line. Okay, problem solved. 14, annuity. Now let's forget about annuity. It's given, 15, it's given that the present value of 5,000 at 12 years is this. it's almost the same, right? So this is almost the same to the question we just solved. Now I have 12 years. So I want semi-annually. Right, we are repeating, right? So well, let's do it, right? Just since we have enough time. 5,000 divided by 1950.61. Get the answer? Okay, raised to the power of, put a bracket, 1 divided by 12. Put enter. So that's my 1 plus I, okay? Once I know that, what do? I need to take another fractional power. It actually takes square root. So I can do it here. I believe that's the square root. Okay, minus 1. Hit enter. Okay, times by 2. So 8%. By the way, you see, when I use calculator, I don't write down any intermediate values. I calculate everything actually in one step. That's another practice you need to learn. Okay, when you are working on the exam, the way I usually do is first time when I solve all the questions, I solve everything in one step. Okay, and then once I have extra time to check, I will do it step by step, writing down the intermediate values and always use some kind of approximations to do it. In the end, the two answers should be very close. If there's anything fundamentally different, something's wrong, either the first time or the second time. Okay, move to the next one. We have annuity, right? And there are 6 years, but it's quarterly, so there are 24 payments. It's a little bit more than what I can handle. Give up. Found the annual nominal discount rate convertible quarterly equivalent to an annual nominal interest rate of 6%. Okay, this we can do. So first of all, we know nominal interest is 6%, convertible monthly. So I divided by P. P is 12. Raised to P, that's 1 plus I. On the other hand, I will need to use nominal discount to express the same thing. 1 minus the quarterly. So P is 4. So, but here it should be negative 4. Okay. Again, that's because if you do 1 minus something that's less than 1, if you raise to a positive power, it will be always less than 1. In order to go to something greater than 1, you need to raise to the negative power. That's why here is negative, here is negative. Well, they are the same. What you can do is, well, actually don't need to go to 12 because you can go to 1 quarter. 1 quarter is 3 months, if that helps. But anyway, we have calculated, so it really doesn't matter to take care of that kind of small things. It's the same difficulty for your calculator. So raise the power 12. So I get my left-hand side. Take fractional power. So it's 1 divided by negative 4. So it's 0.25. But it's negative. So remember to put negative. Okay. And 1 minus it. Now I can do minus 1. Then I get a negative number times by 4. Okay. Of course, we need to ignore the negative because I didn't times by negative. So what do we have? So it's 5.94. 5.94. So it's C. Question D. What is the monthly payment of this? Well, please go by. Question 19. Which of the following is not correct? Okay. These type of questions, well, usually it's a huge deal to many of you. You get lost. But sometimes and oftentimes, the answers come from the answers. Right? They are contradictions within the 5 options. So let's forget about what it is. Okay, let's look at 5 options. This is some future value. Okay, right, and this is the present value. From the present value to future value, you times by the accumulation factor. There are n years. So A and C, either both are correct or both are wrong. Since there's only one answer, they must be both correct, right? So that's logical argument. right? You try to analyze which is wrong. Okay, and then if you look at A and B, well, they are close, but the number of years differ a lot, right? In the first is MP, the second one is MP, the first one is N, and they also have different interest rate. We know B is incorrect. That's because once you put P, upper P, your N must be the number of years. Okay, and your interest rate is the annual effective. That's why B is incorrect, because if you put MP, that means you have MP years. In each year, there are P payments. So you can tell the total payments will be more than what we need. But of course, you can argue that I'm not familiar with this notation. Okay, so but anyway, you shouldn't pick A or C, right? Because if you pick A, that means you also need to pick C. Okay, they come together. Okay, so here D is correct. That's because we can come back later to this. Question 20 is rather complicated. So let's see how many questions I already solved. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, let's forget this. It's already 9 questions, right? That's 45 points. That's enough to make you pass this course safely, right? And so far, I didn't use any annuity formulas yet, right? And you have 11 questions that you can wildly guess, and it's not easy to guess all of them wrong, right? I mean, you can even stick to A, stick to B, stick to C, stick to D, stick to anyone for those you don't know, right? And you will still safely pass this course. That's why strategy really matters. When you are writing an exam and you don't have the right strategy, that's the separation line for passing and not passing. Okay, but of course, what we want is more than that. So now let's. I briefly mentioned, because I already put the solutions already. So I don't want to go into exactly the details. You already have the formulas, and so let's analyze. Okay, start with question 1. Maximum receives annuity that pays 125 in year 1, 150 year 2. So always draw a timeline and label the payments. Until the last payment of 500. So first you need to figure out what would be the number of years here. And okay, I start with 125. I go up by $25 each year. Between I need to figure out, right? So 500 minus 125 divided by 25. So that is 15, right? So here is 15. So I know here it's 16, right? Because the first one is the same number, right? So 125 minus 125 is 0. So 25 times 0, 0 corresponding to year 1. So 15 corresponds to year 16. Obviously, this is an increasing annuity, but it's not 1, 2, 3, 4, right? So for all the increasing annuities, if the amount is fixed, you need to figure out that amount, and that amount is 25. And make 25 the first one. Of course, you have 100 left, right? That's how you decompose, right? So it's always the increment be the starting value of your increasing annuity. Then the second one would be 50. Because the second one is 25 times 2. The third one is 25 times 3. Right? You see, all of them are the level. Right? In the end, you will have 100 and 400. Right? we want present value. So it's 100. This is a level annuity immediate. Okay, the other one is a standard increasing annuity immediate. So your financial calculator can handle this directly. This is not. This is a scientific calculator. This, remember the email I sent to you before the exam? Once you get an exam, the first thing you do is not to work on question 1. The first thing you do is to write down the formula of IA. Right? I believe all of you can memorize this in a few minutes right before the exam. And once the exam starts, write it down. Okay? Everything else, it comes from there. Of course, by now you have textbook. You can go back to check. We already solved a lot of questions here. Question 6, we want to know the accumulated value. And it's decreasing, right? So we do the same kind of decomposition. And the first thing you do is to find out what is the difference, right? I shouldn't use D, because D, we always use D for discount. But anyway, the decrement, right? 5,000 to 4,950, the difference is $50. So it means that's how you decompose. But this is a decreasing, right? So you need to figure out the number of years, right? So you start with N. N is 10. 10 times 50 is 500. $45. So this is year 1, okay? For year 2, well, this will be the same because it's the second part, it's level, right? And then I go down, it's n minus 1 times the difference, so it's 50. So let me write this. Times 9, this is second year. Times 8, this is the third year, goes all the way to the 10th year. Right? So what would be the accumulated value? So I do have a level annuity, and since I want the accumulated value, so it's going to be S. I have 10 years. Interest rate is I, 5%. 50 is my factor, and this is a decreasing annuity. Decreasing annuity. So I have a D because I want AV, so it's S. Right? So again, the only formula we need is IA. DS. We have this kind of, let me give you a quick load tree. So assume you know IA. Okay. Once you know IA plus DA is M plus 1A. Right? Okay, so if you know this, your calculator gives you the right-hand side. So you know DA, right? So once you know DA, DS equals 1 plus I to the nth times DA. So limit the number of formulas you are trying to memorize. We only have very limited processing power. Okay, you wouldn't be able to memorize all the formulas. Okay, there's no way you can do that. That's why I always emphasize the relationships between all those annuities, PV, AV. The fundamental is always in the immediate. Once you are able to figure out the immediate, everything else comes rather naturally. Okay, I already showed here is how the load tree works. Of course, you can also try to calculate PV, right? Because usually, maybe you are more comfortable with present value. Once you know the present value, AV is 1.05 to the 10th times by PV. Right? So it doesn't matter which one you take. Brian receives inflation adjusted annuity at the beginning of each year. So you know this is a due for 20 years. So N is 20. The first payment is 1,000 paid now. The next one will go up by 10%. So now this is what we call the compound increase. You can do it by formula, meaning you convert it to J, and once you get J, your present value would be a double dot because this is an annuity due. The first payment is 1,000, so let's times by 1,000. You have 20 years. 20 stays the same, but you have a new interest rate. Okay, interest rate is not I, it's not 16%. You need to convert it to J, which is about 5.45%. Okay, once you are able to do the conversion, again, your financial calculator gives this result directly. You don't even need to memorize any formula for that. But what I usually do, I hate memorizing formulas. So what I usually do is I directly write it down what it is. Times by 1.1 to 19th. Okay, I want present value, right? So I want present value. All I need to do is to discount all these 20 payments. By the way, even you apply the naive method, you can solve this. Maybe you need 3 to 4 minutes, right? There are 20, right? You can divide by 1.15. 1.15 square goes all the way. Right? Your calculator can handle. It's not you doing the work. So you probably need to be careful on that, but it is doable. 20 is doable for sure. Okay, maybe 3 minutes you should be able to solve this without knowing any formula. Again, but what I usually do is I think this as a geometric sequence. So what I do is okay, and then you just need to figure out the common ratio. Okay, how do you figure out the common ratio? Use the second one divided by the first one. So what you get is 1.1 divided by 1.16. I'm running low on space. So the 1 minus the common ratio. Okay, on top would be your first term. 1 minus your common ratio raised to the power of n. How many terms? I obviously have 20 terms. So this is what I usually do it. They will give you the same result, obviously. 8 solved. 9. A special annuity provides annual payments of 100 at the end of year 1, 95 in year 2. So it's decreasing until 60, 100, 95, goes all the way to 60. So you need to figure out what would be the corresponding year, right? This is relatively short, right? You can even count. So 2, 3, you can write down. Okay, this should be 9. So let's put 8 down here. It's 65. Okay, and then payments actually continue at 60 per year, payable at the end of a year for another 5 years. So you will go from 10. 10 is also 50. Goes to 14. Here I have 5 more payments. That's why I put a note. So in total, there are actually 6 payments with amount 60. Okay, so here I have 5 plus this is 6. Okay. Now let's do decomposition. Okay. All of them have 60. The rest is bigger than 60. Obviously, I should use 60 as a level annuity. So let's do 60, 60, all the way 60. So I have 14 payments of size 60. So here it's 40, 35, goes all the way to 5. All right, so this is 5 times 8. 5 times 7 goes all the way to 5 times 1. That is a decreasing annuity. Right? So for present value, I have 60 as level payments for 14 years. Okay, that is a standard level annuity immediate. And then I have a decreasing annuity that goes from 40 to 5. So let's factor out 5. Then it goes from 8 to 1. So it's a decreasing annuity with 8 years. Right? Okay, then plug in your formula to get the result. Question 11. Determine the accumulated value at time 8 years of payments of 100, 150. So first of all, this is continuously payable. Okay, that is a huge difference. The amount is 100, 150 goes all the way to 8 years. Right. So first, you need to figure out how many years. What would be the payment in the last year? This is continuous payable and is increasing. The amount is fixed, right? The increment amount is $50 per year, right? It goes from 100 to 150 to 200. So it's easy to see the amount is fixed, 50. Again, figure out that amount, make that amount to be the first one. And the second one would be 50 times 2, goes all the way to, this is 50 times 8, right? Then what's left is 50. The second 50 would be the level payment, which always stays. That means the last payment is actually 450. Again, there are 5 years, right? Okay, using your fingers also works. I want accumulated value. So let's do the level part first. This is continuously payable. So you have a bar on top of S. S means accumulated value. And the bar means it is continuously payable. So this is a level annuity continuously payable for 8 years. And then I also have an increasing annuity. Okay, so here I only have bar on top of S because this is a standard arithmetic increasing annuity. Okay, we also have formulas to get everything down. So let me mention one more thing when we have this. So when we have a bar on top, everything is nearly identical to the standard version, meaning its standard is Annuity Immediate. The only thing you need to change is change I to delta in the denominator. So we also have something divided by, right? Divided by I is Annuity Immediate. When you work with continuous version, when you work with continuously payable, you divide by delta. Okay, what is delta? Delta here is log 1.07. So for instance, here would be 1.0728 minus 1. Let me erase those dots. Originally we divided by I, right? Now we divide by delta. Okay? Plus 50, and then you will have annuity due down here. That stays the same. Okay, minus n is 8. And then you divide by, for increasing annuity, you divide by I. So here you divide by delta. So the denominators, so here we have two denominators, we change those two. The rest is the same. So that's the difference. Question 12, we want to know the present value of a continuously payable stream that is made at a constant rate for 6 years, from 1 to 7. So I want to know the present value at 0, but the payment is from 1 to 7. So obviously I already told you here we have 6 years. So integral from A to B, payment is 10. And then for each payment, I want to discount back to 0. So I start from 0, not 1, to the current time t. Delta S, delta is a constant, so 0.04 ds dt. So I have 17, this is negative 0.04 t dt. Right, so calculator should be able to give you the answer from here. 14. Okay, so for those ones, I actually think they are not difficult because there are two methods. I don't like the one that is mainly given in the textbook. I always ask you to convert this into a standard annuity. Right? The trick thing here is piecely payable at the beginning of each month for 5 years. And what we have done here is there's a mismatch between the frequency and the discount rate we have. Right? Discount rate is for 1 year. Here we want the payment to be made at a monthly basis. So I use J to denote that. Right? So it's 1 minus 6%. Negative 1 would give me the 1 plus I. But now I want to get monthly. So it's negative 1 over 12. That would be the monthly accumulation factor, minus 1. So I directly give you the answer. This J is the monthly interest rate. Of course, it's effective, right? So now what do we have? So now 1 stands for 1 month, okay? 600 per year, so which means it's so 50 per month, right? It's level, right? I will need to know how many months I have in 5 years. The first one is actually at 0. So in total, I have 5 years, which means I have 16 months. The last payment would be at month 59. So this is a level annuity immediate. Immediate, let's put 2 dots. I have 60 payments. The interest rate is not I, but J. I want the effective monthly interest rate. So convert it into monthly, and the rest, let's give it to the calculator. 16, determine the accumulated value of at time 6 years of payments 100 at the end of first quarter for 6 years. So there are 6 years, and the payment is on a quarterly basis, meaning there are 24 payments. 4 minutes, maybe you should be able to get the result one by one. But of course, let's don't do it in a naive way. So we convert time. Okay, so that's at least my preference. So now 1 stands for 1 quarter. Okay. Here is 100. Here would be 110. The next one would be 120. Goes on and on for 24 quarters. Okay, so each one is a quarter. Time unit is quarter, not year. So your first job is to figure out what would be the quarterly interest rate. So 1 plus I, 0.08 quarter. So raised to 1 over 4. Right, 4 quarters a year minus 1. That is my quarterly interest rate. Okay. Now I have done the first step. Okay, this is an increasing annuity. I easily see that. And we need to do decomposition. Let's keep 10 for the first one because that's how it increases. Right? It increases as 10. Leave that for the first one. Whatever left would be your level portion. So the level, not 100, 90. So 90 would be the level part. Okay, and what's the next? 10 times 2, 90. 10 times 3, 90. Goes on and on. 10 times 24, 90. I want accumulated value. So I have 90. This is an annuity immediate. That would be S. 24 at J. So here 2 things changed. The first one is number. Number is not 6 anymore. Number is 24 because my unit is quarter. So I have 24 quarters, and the interest rate is not I will need J because the current time frequency is a quarter. I need to know the quarterly interest rate, which is J in my notation. Right? So IS and IA differ by accumulation factor. Okay. What is the monthly payment on a loan of 10,000 to be paid back in equal monthly? Right. So we are doing the same thing monthly. We need to convert to J. So what they have is here nominal interest rate 6% convertible monthly. So this is easy. So 0.5% is the effective monthly interest rate. Then let's figure out how many months are 5 years. Each year has 12 months. So I have 60 months over 5 years. I want to know what would be the equal payment. So this is X, I don't know. Since it's made at the end of the year, so it's at the end of each month. It's an annuity immediate for 60 terms at interest rate J. In the end, this should be equal to the original amount I borrowed, that is $10,000. Well, this you actually don't need to calculate. Your financial calculator can give you the payment option. Okay, you need to give N. You need to give J. J is interest rate. So in my calculator, that's I and Y. Okay, it's always ignores the percentage. So type 0.5, not 0.005. Okay, it's multiplied by 100. So, and you will need to know the present value. Okay, there's no future value, so there's nothing coming in by the end. And then you want to compute CPT, PMT. So you'll get the answer from your financial calculator. Here we are at the last one. Determine the present value of an annuity that pays 10 at the end of the first month, 15 at the end of the second month, and goes on and on for 2 years. Suppose the annual effective interest rate is 5%. So we've already done quite a few, so we know the best way to do is to convert the annual interest rate into monthly. Right, into monthly, so I raise the power to 1 over 12, then minus 1, that is my monthly interest rate. It is about 0.4074%. I write it down here to show you. When you are working on the exam, use your calculator to store the number. So you can use, once you get this number, you can use STO to store to a position. Let's store it to the first position. And anytime when you want to use it, you simply recall 1. Then that will give you J. Right? Save you time to writing everything down. Right? I'm at least that's my suggestion. And then when I finished everything, when I go back to check, I will write down the intermediate values. You know, that takes time. Right? If I don't have time to check, maybe that's okay. The next step is to decompose. Right? Again, you can easily see this is an increasing annuity, 10, 15, 20. The amount is 5. So break it into 5 times 1. Whatever left would be your level portion. Second one is 5 times 2 is 5. Goes on for 2 years. So 2 years, there are 24 months. Okay. So I want to know the present value. So the present value would be equal to 5 times, this is a annuity immediate for 24 terms at interest rate J. And I also have an increasing annuity again for 24 terms at interest rate J. Now, calculator gives you the answer. That's the end. Right? So we actually even have additional time. When you are working on the exam, when you have, let's say, 5 minutes left, do not start any new question, use that 5 minutes. Sometimes I would even use 10 minutes to recheck whatever I did before. I will need to make sure I get 100% correct on all the questions I actually know. It's, to me, I don't want to have a question that I know of but not getting the points. That is something I can bear with. So in the end, I always leave some minutes to recheck my previous calculations. It's a good practice for any actuarial science courses because they are always heavy calculations. And I am 100% for sure you will make mistakes. Let it be an exam or homework. Okay, it's very, very common to type anything wrong on your calculator, right? And oh, by the way, you should be very familiar with your calculator. One thing any test manual would suggest you to do is you need to know your calculator, whether it does according to the correct order. An example would be to calculate, because for this course it's okay, but for SOA exams they will reset your calculator, right? So the first thing you do is to work on this. So it's 1 plus 2 times 3. So it's 7, right? So 7 is the correct answer. But it's possible that your calculator give you 9. That is because they do, once you hit 1 plus 2, your calculator directly gets 3. And then 3 times 3 is 9, right? So that's how it is processed. So you should always set it to this mode, okay? And whenever you have something rather long, put a bracket to separate. I already showed you, right? For instance, if I want to do 1.05 to this fractional power, I always put a bracket to enclose 1 over 12 so that I can continue to work on anything. For instance, so what I would do is 1.05, put a bracket. So, not there. So 1.05 times raise the power and then put bracket. If you put a bracket, the computation will not be calculated until you put the other side. So I can do 1 minus 12. So it will do this first. And then I can do 1 divided by 3. And then I put a bracket, okay? Then I can hit enter. So that helps you to do everything in one step. That will save you a lot of time at exams. Let me stop down here.